Hello and welcome back to the series of Machine Learning with Python. I am Shruti and I am your instructor for this course. So let's begin. So in previous videos, I have already discussed with what exactly the machine learning is, then what is simple linear regression, multiple linear regression, polynomial linear regression, what is your decision tree, random forest, then KNN, etc. So in this video, I am going to cover what is logistic regression, what is support vector machine, in which linear support vector machine, non-linear support vector machine, and what exactly the support vector regression. I'm going to cover all these topics with its implementation. So let's begin. So earlier you have saw what is linear regression. Also we have covered what is dependent variable and what is independent variable. Let's quickly summarize for for those of you who were not aware of this terminology. So dependent variable is nothing but the variable which you want to predict. For example, I want to know what will be the sales on, for example, suppose let's say 17th of November. So cells become your dependent variable, and or say you can say it is a target variable, and this depends on various factors like what is the season out, then what products you sold till day, then is there availability of product, how the product quality is, etc. That is this is your never ending factor or say features that leads to cell. So this is your called your independent variable or say predictor. Okay, so we have conducted an example of equation. Here you can see equation of your line. So from which will say that this y is your dependent variable and x is your independent variable. So here, look at the graph. We have values of x and values of y. If x increases, the values of y also increases. So in simple linear regression, we have conducted an example of your salary data set where dependent variable is your salary and independent variable is your years of experience. So as your years of experience increases, your salary also increases. So here you can see this graph of your salary data set. Okay, so that's what your linear regression is. So regression is basically divided into three types called linear, polynomial, and logistic. We have already covered what exactly the linear regression, polynomial regression with its implementation. Now today let's discuss what is a logistic regression. Okay, so whenever you want a result in binary format, which is used to predict the outcome of a categorical dependent variable. So we'll get an outcome such as your discrete or says categories such as yes, no, 0, 1, true, false, high, low, all those things. So why we are not using a linear regression? Okay, so in linear regression, the values of y or values you need to predict is in the range. Though both are predicting linear probability, that's then why not this linear regression? Why we are using logistic regression? So in case of your logistic regression, you will get the values of y, or say you just have a two values either 0 or 1. So it is not entertaining the values below 0 and or say values above 1. So main rule of your logistic regression is the value of y should be in between 0 and 1. So let's consider the example here. So we are considering a simple example of your rain when you have to classify it's raining or not. So in this case, if we use a simple linear regression, we'll specify some threshold value on which the classification is done. Okay, so here, let's say actual class is it's raining today and the predicted value or say continuous value is 0.45. That is your below 0.5 here. Here you can say this is 0.45. So then this data point will be considered as it's not raining today. So this will lead you to the wrong prediction. So in such cases, we cannot use the linear regression for this problem. So such type of classification, here we have a linear regression comes in the scene, where the value strictly in the range between of 0 to 1. So how we'll do it? So in case of your logistic regression, instead of fitting a regression line, we fit this S curve or say S-shaped logistic function to predict to maximum values in between say 0 and 1. Okay, so this curve indicates the likelihood of something such as whether it's raining or not. So, and like say your email is spam or not. This is one another example. Again, another example is the cells cancerous or not. So, to obtain this, S curve will use a logistic function or say sigmoid function. So, just understand this concept of your sigmoid function in order to map the predicted values to predicted values. We use the sigmoid function. So the function maps any real values into another value which comes between 0 and 1. So in machine learning, we use the sigmoid function to map the predictions to probabilities. So here we have an equation of your sigmoid activation function. So f of x is equals to 1 upon 1 plus e to the power of minus x. Okay, so let's understand with the example. As we are expecting our classifier gives and set of output or say a classes based on the probabilities. We pass the input through prediction function. It returns a probability score between 0 and 1. Suppose we have two classes. Let's say take the Donald Duck and Mickey Mouse. So here we basically decide a threshold value above which we classify into a class 1. If the values goes below the threshold, then we classify it in case of your class 2. Okay, so as shown in this graph, we have chosen the threshold as 0.5. The prediction class returns the value 0.7. So we would classify this observation as class 1. Say let's say this Donald Duck. And if the values goes below threshold, that is 0.5, will get 0.2. Then we classify it in the class called Mickey Mouse or say class 2. So the bookish definition of your regression is using relationship between variables, finding the best line or say best fit line or regression equation that can be used to make the predictions. So we had covered the example of your salary data set in which simple linear regression, in case of your simple linear regression in which we obtain this graph. So using training data, years of experience and salary. So you can see this regression line is obtained here is the closest to many points as possible. So that is, it gives us a minimum error. So we have one linear equation that is used for a new data so that one is able to predict the required output. So your y is your dependent variable, then population slope coefficient is beta 1, x is your independent variable, beta 0 is your population y-intercept, and this is your random error epsilon. So here, as I discussed, beta 1 is the parameters, also called your weight. Then this epsilon is the random error term whose role is to add the bias. So this equation is the linear equation that needs to be obtained with the minimum error. So values of beta 1 and beta 0 must be chosen so that they minimize the error. Okay, so to check the error, we have to calculate the sum of the squared error and tune the parameter to try to reduce the error. So we have this equation. So now here you can see the equation of cost function. So how to reduce this error? So this j theta represents you a cost function which represent the optimization objective. We create a cost function and we minimize it so that we can develop an accurate model with the minimum error. If we try to use the cost function of linear regression in logistic regression, then we would have no use. because it would end up being a non-convex function with many local minimums, in which it would be very difficult to minimize the cost value and find the global minimum. So here you can see the graph, which is a non-convex function, which is of non-convex function. So for logistic regression, the cost function is defined as by using this log minus log of h theta x if y is your 1, and log of 1 minus h theta x if y is equals to your 0. So cost function for your logistic regression is this. Okay, when we compressed, and we will get the graphs like this for y equals to 1 and y equals to 0. And whenever we are compressed these two functions into a single equation, then we'll get this j theta like this. Okay, now let's understand the concept of gradient descent. As I already discussed, whenever you we have calculated the sum of squared error and tune the parameter, try to reduce the error. So now the question arises is, how do we reduce this error? So well, this can be done using your gradient descent. So the main goal of your gradient descent is to minimize the cost value, that is say this j theta. Well, what is then gradient descent? So gradient descent has analogy in which we have to imagine ourselves as at the top of the mountain valley, and left standard or blindfolded. Our objective is to reach at the bottom of the hill. So filling the slope of terrain around you is what everyone would do. So well, this action is analogous to calculating the gradient descent. So taking a step is analogous to one iteration of update parameters like this. So choosing a perfect learning rate is again important task, as it depends on how large of a step we take downhill during each iteration. So if we take a too large or of a step, we may step over the minimum. However, if we take the small steps, we will require many iterations to arrive at the minimum like shown here. So this is the way to fit a line or say your regression at every iteration. So here you can see this graph. Okay, so it reduces your error. So, as I already discussed, so the logistic regression is a machine learning algorithm which is used for the classification problem. It is a predictive analysis algorithm based on the concept of your probability. So, we can call our logistic regression a linear regression model, but the logistic regression uses more complex cost function. So this cost function can be defined as your sigmoid function or your logistic function instead of your linear function. So the hypothesis of your logistic regression tends to limit the cost function in between 0 and 1. Therefore, the linear function fails here to represent it, as it can have the values greater than 1 or less than 0. So in order to map the predicted value to the probability, we use the sigmoid function. So this function maps any real value into another value between 0 and your 1. Okay, so how does it work? So suppose we have to classify a mobile budget, we don't know the price of upcoming phone which is not yet launched. So that's why we don't know its price. So firstly, our mobile phone using old one, and then we'll give your classification result only. So here we have to classify the mobile phone is in our budget or not. So suppose we have 4 features. Consider the ratings for each feature out of 5. The features are camera quality, let's suppose C. Then this R is your RAM. Then this Pro is your processor, and its price is your PRC. Okay, so these are the parameters, and you have to predict the price of upcoming mobile from its ratings. So this M1 is your mobile phone number one, which has existed with its having a camera rating 3, with RAM rating 4, with processor rating 3, and whose price is 5K. Mobile number 2, same, the camera quality is 4, RAM rating is 2, then processor rating is 2, and its price is 10K. And mobile number 3, the camera quality having a rating 4, RAM rating having a 3, and processor rating having a 2, whose price is 7K. Now the upcoming mobile, the company giving a rating, its camera quality of 5, then the RAM rating is 5, processor rating is 5. So we have an equation that is of linear regression, where this y is the price in our case, w is the weight, and x is the feature. From training, we'll get, suppose, a weight. Let's assume after the we will get the weights here after training, that is 7832, and this one is here 1. C is the camera rating, this 5. R is again this 5, and this pro is again your 5. Okay, so we set this value, and now we multiply and add both like this. This 7 into 1 plus 8 into 5 plus 3 into 5 plus 2 into R pro, that was 5. So here you will get the value, that is 72K, and we'll convert it into percentage, that is your 72 percentage. Now we will use a sigmoid activation function to fit this value in between your say 0 and 1. So that is, if the value above 0.5 or say 50%, then it is not in our budget, or say out of budget, else it is in our budget. So now it takes your features and or say your labels, that is your training data, fits a linear model, weights and biases, and instead of giving you the price of your mobile phone, it will give you the logistic result. So this model shows you the mobile phone is out of budget. So this is how. So it will gives you the result that is out of budget. Okay. So let's implement this. So we'll implement this in your Python. We'll use this. For this task, we'll use a social network ads.csv dataset. So this is the glimpse of the dataset. Okay, so there is a dataset which gives you, which contains the information of your various users obtained from your social network sites. So there is a mobile making company that has recently launched a new mobile. So the company wanted to check how many users from the dataset wants to purchase the mobile. For this problem, we'll build a machine learning model using your logistic regression algorithm. So the data set shown here is like this. So in this problem, we will predict the purchased variable like this. So which is your dependent variable by using the age and this estimated salary. Those are your independent variable. And we are expecting the graph like this. So again, here we'll implement during implementation of your logistic regression, we'll use the same steps as we have done in case of your previous topics of your regression, as well as classification in decision tree and simple linear regression, etc. So the steps are again the data pre-processing, then fitting logistic regression to the training state, then predicting the test result, test accuracy of the result, creation of your confusion matrix, and say you're visualizing the test result. Okay, so here we have this data set. This is our data set. So first step is we'll pre-process and prepare the data so that we can use it in our code efficiency. So it will be the same as we have done in pre-processing data pre-processing topic. The code here for the data preprocessing is same, like importing the important libraries and importing the data set. Okay, so let's run this. Okay, now by executing these lines of code, we'll page the data set. Now we'll extract the dependent variable and independent variable from the given data set. Okay, so this is the step where we are extracting the dependent variable and independent variable. So we have taken 2, 3 for x, our dependent variable, though that is your age and your salary. So those age and salary are are at the index of 2, 3. That is 0, 1, 2, 3. So here we'll take this 2, 3. And we take here 4 for your y variable, because our dependent variable, that is your purchased, is at the index 4. So we'll extracting this dependent and independent variable. Okay, so here data set is like this. That's why it is not giving you an output. Okay, now our next step is to split the data set into the training and testing. So here you will have a splitting code like previously we had done. Now in logistic regression, we'll do a feature scaling because we want accurate results of prediction. So here will only scale the independent variable because dependent variable have 0 and 1 values. Here you can see this is our dependent variable. So it contains the values in between in zeros and 1. So here we'll do the feature scalings on your independent variable only. Okay, so just run this code. So you will get this. Now the next step is we'll, we have well prepared data set with us. Now we'll train the data set using your training set for providing you a training of fitting the model to the training set. So we'll import this logistic regression class from the library called sklearn. Okay, after importing the class, we'll create an object called your classifier and use this object to fit the model to the logistic regression. Okay, so we'll run this code. Okay, so by executing the code, we'll get the output like this. So here, our model is well fitted to the training set. Now our model is well trained on the your training set. So we'll now predict the result using your test set data. So for predicting the result on test set data, so we'll have this ypred is equals to classifier.predict xtred. So after executing this code, the new vector or ypred will be created under here. You can see. So this corresponds to the predicted users who want to purchase or not purchase the mobile phone. Okay, now we'll create the confusion matrix here to check the accuracy for the classification. To create it, we need to import the confusion matrix, this confusion matrix function from your sklearn library. So after importing the function, we'll call it using the new variable called your CM. So the function takes the two parameter, mainly your say y test, that is your actual value, and your ypred, that is your targeted value written by the classifier. So here you can see the code for the confusion matrix. So after executing the code, we'll get or will create the confusion matrix like this and we'll get the values here. Okay, so now from this confusion matrix, we again can obtain the accuracy of the predicted result by interpreting the confusion matrix. So here we can interpret it by using the correct output and your incorrect output, as I already discussed with you how to find it. Then the next step is we'll visualize your training set. To visualize the result, we'll use this code. Okay. Now, when we run this code, we'll get this your result. So, in this code, we imported the color listed color map class, which is in case of your matplotlib. So, we have created the color map for visualizing the result. We have created two variables. Okay, so that is your x set and y set here. And to replace this your x train and y train. After that, we use this nm dot mesh grid, which is used to create your rectangular grid. So here you can observe the rectangular grid. So which has the range, that is your minimum -1 to maximum +1. Okay, the pixel points we have taken is here 0.01. Okay, to create a filled contour, we have used this mtp.contourf command. So it will create a regions of provided colors. Let's say you have purple and green here. So in this function, we have passed the classifier dot predict here. You can see we have passed this classifier dot predict to show the predicted data points predicted by the classifier. So after executing this code, we'll get this. Okay, same graph will do for your testing. So here, in case of your testing, there are some green points. Here you can say these are your green points within your green region. And we have this purple points within your purple region. All these points are in the observation from the training set, which shows you the result of purchased variable. So this graph is made by using two independent variables, age in case of your x and estimated salary on your y-axis. So the purple point observation are of which purchased or say dependent variable is probably 0, that is user who did not purchase the mobile phone. And the green points, green points in the observation are which purchased, that is again your dependent variable, is probably one, that is the users who purchased the mobile phones. Okay, so we can also estimate the graph from that users who are younger with low salary did not purchase the mobile phone, whereas the older users with the high estimated salary purchased the mobile phone. But there are some purple points in case of your green area or region. Okay, so here you can see that is they are purchasing or buying the mobile phones, and there are some green points. Here you can see there are some this green points in case of your purple region. So that means the users are younger with low salary. Those didn't purchase the mobile phone. Sorry, a higher estimated salary. Those are purchasing your mobile phones. So, but there are some purple points in case of your green region and some green points in case of your purple region, that is not buying your mobile phone. So we can say that younger users with the higher estimated salary purchased the mobile phone, whereas an older users with low estimated salary did not purchase the mobile phones. So, will here you can see, here we have successfully visualized the training set result for your logistic regression. So the goal for this classifier is to divide the users who purchased the mobile phone and who did not purchase the mobile phone. So from the output graph, we can clearly see the two regions called purple and green region with the observation data points. So the purple region is for those who didn't buy the mobile phone, and the green region is for those who purchased the mobile phone. Okay, now our model is well trained using the training data set. Now we'll visualize the result for the new observation called your test set. So the code for this test set will remain same as above, the exception except that here we'll use this instead of xtrain and ytrain, here we'll use xtest and test. So here after executing this, will get this graph. So this graph shows you the test result. As we can see, the graph is divided into two regions, that is your purple and green, and the green observation are in case of your green region and the purple observation are in your purple region. So we can say it is good prediction model. Some of the green and purple data points are in different region. We can ignore, as we already calculated this error using your confusion matrix. So hence our model is pretty good and ready to make the prediction for your classification problem. So this is what your logistic regression is.
So these are the concepts of machine learning with Python. I hope you are enjoying the videos. Please keep learning, enjoy learning, and please do not forget to press the like button, share with your friends, and subscribe the channel. Thank you.